So synthetic data update 2026. And first of all, the context. It's in really widespread use already. This was just like 5 minutes, quick query with Perplexity, and it came back and it was pointing out that Evidenza has on its website Mars, Nestle, Ernst & Young, Dentsu, JP Morgan, Microsoft, Qualtrics are talking about Dollar Shave and Google, all these other organizations. And I could have put a list 3 or 4 times as long as this. Major blue chip companies who are in some way, shape or form using synthetic data. There are also lots of providers. One of my favorite websites is Mike Stevens' Insight Platforms. If you don't know it, check it out. And if you type in synthetic, you can search for suppliers by all sorts of criteria and filters. But if you put in synthetic, there are now over 60 with names like Cymar, Synthetic People, Synthetic Society, Deep Sona, Synthetic Users, Simulacra, Electric Twin, and so on and so on. We're also seeing almost all of the big companies offering an increasing range of synthetic data services. Now, this is really different to what happened in the early to mid 1990s, where the only people offering online data collection and internet services were the small companies, the innovative companies. This time round, we've got a big change going on, potentially bigger than the internet, and we're seeing the very big companies coming in very early. And I think that's quite interesting. We're also seeing some real concerns and problems. And this is the one that was published in the New York Times about, 13 days ago, according to that. And that's about a day old. So a couple of weeks ago. And what was the concern here was that they published a story about maternal health policy, and they didn't mention that the polling they did was done with a synthetic panel, or they call it silicon sampling. We might all have different views about how good synthetic data is for polling at the moment. We might have different views for how good it will be in the future. But I think on this call, we would be unanimous in saying, if you've used anything but raw humans, you really do have to say upfront and quite loud. And so obviously that sort of thing makes the whole discussion and debate more difficult. So let's have this overview of synthetic data. It's a model, and a couple of people have been using this expression recently. Andrew Jevons, probably a little bit longer, David Priestley from Ipsos. Don't think about synthetic data as androids or robots. Think about them simply as models. And the best analogy isn't a model like y equals mc x plus c. It's the models that they use to forecast weather. Really complex models, probabilistic models, and they make estimates of the weather for later today, tomorrow, next week. And the further into the future they predict, the worse the models perform. So if we think about our synthetic data, the further we push it from the data that we use to build it, the less likely, the less accurate it is likely to be. But these models of the weather don't contain water, wind, or sun. It's not real in that sense. So when we talk about synthetic data doesn't have soul, doesn't have emotions, it's not supposed to. It's a model. Another nice way, I think, a nice analogy of the sort of models we're talking about is virtual Singapore. So this has been around quite a long time, and it's a digital twin of the entire city. They can simulate things like crowd movements during a festival if they want to do some traffic planning. They can model the flow of wind around the buildings, but it doesn't include everything, and nothing is real. And that's the sort of models we're talking about with synthetic data. So back in last year, I was going to say some time ago, but actually it's only June last year, the ICC SMR code nailed down these definitions. Synthetic data means information that's been generated to replicate the characteristics of real world data. We could have used the word model there maybe, but it means essentially the same thing. So it's a slightly different feel to the word. Synthetic persona means a digital representation of a person generated to mimic the behaviors, preferences, and characteristics of real people or groups. And again, I would say if we had our drafting time over again, and I was involved in the drafting of both of these, then we would probably put in something more like model the behaviors. But I think the meaning is clear. Personas versus data. This is actually almost the difference between a verb and a noun. Synthetic data is a noun. It's a static thing. It could be the answers to a questionnaire that have been generated. It could be the generated transcript of a discussion, but it's a thing. You can print it out and touch it, and it doesn't change. Synthetic personas are agents or simulacra or synthetic respondents. They can generate answers. You can have conversations via a chat interface. They can represent groups of people or they can represent individuals. And synthetic data can be created by synthetic personas, and it often is, or by a number of other methods. So we could use just statistical techniques or machine learning to generate synthetic data. And we'll see a couple of examples of that as we run through. There are broadly 4 types of synthetic data, but 2 of them are the ones we're interested in. Boosting, augmenting, and imputation. So this is where we have real data and we want more. We want to increase the number of people in one of the cells. Maybe we don't have enough young men in the data. So we use various techniques to generate the missing information. And then we have wholly synthetic data, things like synthetic panels. All the data is synthetic. They might be built from personas. They can be built from a variety of other methods. Then we have anonymized synthetic data, and this is used a lot with things like census data. You want to be able to analyze it, but you don't want to reveal who the people are, so they sprinkle in noise so you can no longer recognize it. So it's now synthetic data, which has the same properties as the original data, and it can be used for modeling. And then, of course, software developers have been using synthetic data to test their programs for years. Many of the survey platforms have the facility to generate synthetic responses so you can test your questionnaire. These are just randomized synthetic data. The 2 we're interested in are the augmentation and the wholly synthetic. So let's look quickly at the augmentation route first of all. We're going to use AI and statistics to add real data to increase it. So why do people want to do this augmentation or this boosting? Well, the first is they want to make data collection faster. The last 20% can often take 80% of the time. To avoid some of the compromises when the sampling criteria are relaxed to achieve the numbers. So your sample turns out to be hard to reach. So the sample company says, well, can we have young people in the south of England and can we have men in the rest of the country rather than young men in the south of England? And so you can avoid that sort of compromise. To avoid having to use blended sample sources. So you might be very happy with the data from your preferred panel company, but if they have to blend in other sources, then maybe you're less happy. Some hard to reach samples won't be complete even if you had more time and money. So how can we deal with those cases? Some niches are too small. And one of the early uses we saw from companies like L'Oreal was they wanted to look at small brands and they were doing maybe 1,000 interviews a month. They'd have to do 30,000 interviews a month to really be able to dig into the small brands. So by boosting the samples, they were able to increase the number of brands they were able to look at. So these aren't hard to reach people. These are just, you need a really big sample if you want to reach them conventionally. And you want to be able to dive deeper into completed studies. So you've done a study and then afterwards somebody says, is there a difference between the left-handed people and the right-handed people? And you realize you don't have enough left-handed people to look at that properly. Now you can boost the sample and with some caveats, get some indications of what's going on. And you might want to, in a tracking study, look at the latest wave and try to put a magnifying glass on it to say, is that really a trend? Or do I have to wait 3 months before I should start worrying about this drop in preference or approval or something? So how do we test the quality of boosted data? Well, with all synthetic data, there are 2 things we would like to do. The first is Does it tend to work with this type of question, with this type of market, with these types of people? And the second one is it working this time? And the first one is really easy to test. You take old studies, they could be last year's studies, they could be 3 years ago studies. Remove some of the data, give that data that's still there but with the section removed to the people who are going to do the boosting. They will boost the sample to replace the removed data and then compare the removed data with the boosted sample. Have you made a reasonably good job at repairing that? This is not good enough on its own, but it is necessary. It's a necessary but not sufficient step. Any system of boosting should be able to do this with past studies. Does it work on this study? Well, you get a bit of an indication by that by taking out some of the data that needs boosting. And so if we were short of young men, we'd take some of those out. That's called the holdout sample. Now we're going to boost the sample, not using this holdout information, and we're going to compare the boosted sample with the holdout sample to see whether or not it looks like with this type of data, we can replicate the cases in a way that is good enough for the purpose. Now, I've talked very glibly about comparing the boost, but what does that mean? And probably one of the criticisms that I would have, and some of the statisticians certainly have, with people offering these services, is they will often talk about the boosted data being close to the real data. Quite often, it's the sum of the average differences between the two sets of means. And that's really not good enough, because in any particular data set, you're unlikely, when you're generating boosted data, to be very far away from where the rest of the data is. So it's going to be those sort of categories where you want to look at things, and you're going to look much more than just the means. So other key measures, the standard deviation. So how spread out is the data? When we boost data, it very often has a smaller standard deviation. It's less spread out. You tend not to boost the outliers when you boost data. Where are the 25 percentile and the 75 percentile? What about how flat the distribution is? What about the skewness? In particular, what are the correlations inside the data? So yes, it might generate the means okay, but can I then process that data by doing a segmentation? Can I process that data by doing a driver analysis? That is a much harder test, and those are the sorts of things we need to look at. So another important thing is that you cannot calculate for boosted data standard errors, measurement of errors, estimated sample size using the formula that we've used with genuine humans from a non-probability sample. New options are being developed. They're quite sophisticated. They take a certain amount of effort, but they are fundamentally different ways of drawing up those numbers. So don't just assume that if you see an ESS, estimated sample size, it's what you think it is. Don't assume that leading statisticians would call it valid. One of the reasons is that when we augment the sample, we've increased the apparent N. So we used to have 1,000 people, now we've got 1,200. So N has got bigger. And we've also typically going to reduce the standard deviation. That improves the precision, but it doesn't improve the accuracy. Instead of saying we think it's 50 plus or minus 3%, we might now say it's 50 plus or minus 1%, but we haven't changed the probability of it being 50 at all. It could still be 40, depending on what other problems there are with the study. So, limitations of sample boosting. It's not magic. Done well, in the right cases, it's better than waiting, but it's not as good as having more data. I think pretty much everybody would put it in that category. It's normally better than waiting when done well. It's never as good as having more data. It doesn't reduce the costs that much. You're still collecting, say, 80% of the data that you were collecting before in the old-fashioned way. In fact, most people keep the sample size the same and have some extra analysis because of this. And it's not real time. If you were collecting 100% real data, maybe it would take you 5 days. Now, maybe you can get it ready in 1 day with augmentation, probably 2, because there's a a delay in the augmentation process too. But when we come to wholly synthetic data, that's going to be instant or nearly instant, hours. So these are all the features around the boosting. It's in quite wide stream use. Many of the blue chip clients I'm talking to have it as part of their tracking programs, have it as part of their testing programs. Fully synthetic data. Now, this is the really disruptive one. This is something that could change the way we do all sorts of things. It could massively increase the amount of research that's done. It could challenge the leading companies. It could challenge the panel companies. We don't know. We're not even certain how good it's going to be. One of the really interesting papers that we all need to be aware of is this one and some of the follow-up ones from Google, Stanford, Northwestern. And what they did was they took 1,000 people and they created 1,000 agents, they call them, synthetic twins, other people would call them. And they had a 2-hour semi-structured interview. So the interview was basically qualitative. And they gathered a lot of information about these people. And then they asked a wide variety of questions to real people afterwards. I think it was about 350 more questions they asked after they had built these agents. And they claimed an 85% accuracy between the real answers and the digital twins. Again, this tends to be on mean responses. It doesn't mean that it's got this real depth that we might expect from real data. But nevertheless, if you were looking for answers at that level, that is something that you might say, well, that's worth losing 15% of accuracy to get the information faster, to get the information cheaper. Personas are models, not people. We sort of come back to this point again. Key variations. Sometimes we have personas who represent groups. The term personas for this isn't fantastic. Hopefully, it's one of these things that evolve over time, because historically, we've meant personas represent groups of people, which is what I'm showing you here. But actually, some of the vendors in the space, the ICC code, also allow the term personas to represent models which one per person. And within that, we have digital twins, where each model is based on a real, genuine, specific individual person. And then we have others, multi-donor personas. So if you look at synthetic panels, by and large, they're multi-donor personas. And we can use these personas for qualitative research, and we can use them for quantitative research. So let's run through some of these. So digital twins. These are copies based on real people. So if we think about the synthetic Singapore at the top, that is a representation based on the real Singapore in the picture underneath it. So one-to-one virtual representations of actual people. The input data can be quant, it can be qual, or both. So if you have an online community, you may have done 50 surveys and 10 online discussions with somebody, and you can use all of that information to create the digital model of what that person would say to various questions. And then you can have a qualitative conversation with them, or you can have a quantitative survey administered to them, or some combination of those. And there's a growing range of case studies, and some of them show remarkably good results, some show weak results, and some show bad results. So then you need to look into those case studies and see what they're doing differently. Is it the questions they're asking? Is it the way they built the twins? Is it the market? We are seeing some patterns. Digital twins tend to be a bit more logical than their human counterparts. They make fewer purely emotional decisions. They're equally creative, but differently creative by and large. And on the objective factual scales tend to be very consistent. One of the things we need to be aware of is scope, endogeneity and exogeneity. Digital twins reflect the data they were built on. So when they work, they can answer new questions which are similar to questions asked in the past. If I know your opinion on lime-flavored Coke and cherry-flavored Coke and strawberry-flavored Coke, I can probably make a reasonable guess to your answer on lemon-flavored Coke from the data, even though you've never answered about lemon-flavored Coke in the past. So all of that is endogenous. But we can't go out of that range. So if the donor data is focused on grocery shopping, it can't make predictions about what these twins would have done when choosing a car. That's outside the scope, it's exogenous. And it's one of the things we need to keep an eye on as we move forward. What are the use cases? It's mostly used, and we SMR had a really nice community circle on this, presentations from 3 different vendors talking about it. Big agreement, it's low risk uses are the primary place. Often it's where research would not have happened, and if the results are interesting, they will get validated. So that is lowering the threshold because it's relatively inexpensive, it's very fast, starting to do research in places where research would not have happened. It's used for data exploration to find out what else might be going on. And this reminds me a lot of the sort of what if modeling we get from things like conjoint analysis. Concept and idea screening are a major part of this. The digital twins don't get tired, so you can just keep running ideas past them until you get ones that are worth taking to real testing. Ideation and brainstorming. These AI-based models tend to be very creative. Differently creative, yes, but very creative. Often described as directional. I was talking to one of the panel companies yesterday, and they have probably got every right to feel a little bitter because panel companies are judged on the input, the method, is it a probability sample, what are your processes, and they have to be right. The synthetic data people are by and large judged on their outputs, not their inputs. How close is it to the real thing? And they are getting away with, or their place in the business is directional, not about being right. So now let's look at personas as groups. Well, of course, personas as groups is something we have been doing for a long time. We have been trying to take data archetypes like the Jungian ones and then applying the data to it, or we've been looking at the data and creating personas. What is happening here with AI is really just an extension of that process. So instead of having 2 or 3 researchers sit around the table and deciding what the characteristics of each persona are, we now have AI delving into an enormous amount of data to generate what the characteristics of each group is. And so, use cases, qualitative exploration, looking to explain what's happening in segments, ideation and brainstorming, and also, interestingly, interrogating datasets and integrated datasets through the lens of personas. So if you can have an enormous amount of real data by creating these personas on top, which will then give you lenses to interpret that data, that's something that's been done, and that's really quite interesting, I think. And then we get synthetic panels. This is probably the one that is going to be the hardest for most of us to accept as ready to use. Each model represents one sample point, but each model is not built from a single person. Often they're built from large amounts of panel data. So panel companies have got enormous amounts of back data. If they had only had one dimension, we might assume that the data would be in a bell curve. We'd generate synthetic personas mostly in the center of the bell curve. But actually, they have got hundreds or thousands of dimensions across this data over time. So it's a multidimensional space, multidimensional bell curves within that, and the synthetic personas are generated to fit that complex space. And you can add non-survey data to the process. So you can say, we will add in media data, we will add in social media listening data to the process. So it's not just the past survey responses, but the other things as well. Synthetic panel use cases. Again, people are still talking about low-risk research. People are using this phrase directional still. Exploring markets, idea and concept screening. This is the one that we see a lot. At several of the conferences recently, we've seen Reckitt and Lane Rodrigo talking about using NIQ bases, and they have a synthetic panel which gives you testing within a couple of hours of the results being ready. So where speed is essential, where you want it now or you want it in 1 or 2 hours instead of tomorrow, then this is where it's coming into play. So this brings me back to scope. I mentioned endogeneity and exogeneity in terms of digital twins, where the scoping limits are pretty clear. With the panel, they've obviously covered a lot more things in the past. But if you've got a panel that had never researched sex toys, it's going to be really hard for past survey data to help you. And they're also backwards looking. It's hard, for example, to evaluate the opinion about the recent Artemis moon mission from last year's survey responses. So those are some of the scoping issues. What some of the synthetic panels are doing is they're adding other information to it, such as the media data, transactional data, loyalty card data. And of course, that makes out of scope potentially more plausible. However, it also raises the possibility that you could have got that result without any survey data, real or synthetic. If you have enough of these other pieces, then you can make a pretty good projection of what is going to go on. So it's quite interesting that we're getting these other sources of information blended with it. It reminds me very much of the way that Nate Silver did his forecasting of election results, where he would aggregate polling results, but he would also look at spend. He would look at historical factors. He would look at local records. He would look at the economy in order to make those estimates. And we might see a lot more of that coming in with these augmented, fully synthetic panels. So how do we evaluate these personas? Well, we have the same two questions as we had before. Do they work in general in this field? And we can use past studies to compare the results. So we can tell whether or not the questions we tend to ask often work, or do they not often work? Do they work for this project? That's really difficult. Sometimes it's coming down just to plausibility. Sometimes you can test it afterwards. So if you find that you are testing all of the concepts that are indicated as being a winner in your synthetic testing process, and they are all winners, that's a plus mark. If they're not, well, that's a pretty big negative. Or you could take individual questions from this study and put them on an omnibus and get a comparison that way. But there isn't a good way of testing whether it's working this time in the way that there often is for boosted data. If we're evaluating quant personas, then one of the things we need to remember is if you get one project right, it doesn't mean that the next project will work. It doesn't have the sort of mechanistic safety that asking survey questions to a probability panel sample would do. There are no agreed equivalents to SIG testing. So you'll get some measures of variance of precision, but really it's very hard to understand how valid it is. And getting the means right is relatively easy. Here is a new breakfast cereal. How many people will like it? That's not too difficult to get broadly correct. But which subgroups will like it, and what are the drivers of their choice, and how should we target the marketing? That is much harder. And maybe this is what people mean by directional. It will tell you roughly how good it's going to be, and you will have to do some real research to find out why and with whom and how to trigger that. So we do need to really explore this. What does directional mean, I think? Evaluating qual personas. Most quant methods of assessing are not suitable for quant. So I really hate it when you see people say, how many words were suggested? Or how many ideas? It's really not the point. It's how much understanding did you get from the process, not how many words there were. And were the same ideas and explanations found? That isn't a good test either, because different but equally good is perfectly okay. In fact, it may be preferable in some situations. So we tend to look at plausibility. Was the research helpful or enlightening? Can we evaluate the findings over time? And some people are using the distance in semantic space. So every phrase can be embedded. It's a multi-dimensional vector. And like any vectors, you can calculate the cosine between them, which is like the correlation coefficient. So embedding vectors which are closer together are more similar. However, the science of how that turns out into interpretation is not settled. And secondly, very few qualitative researchers are going to be sold on the argument that the cosine of the embeddings is close, in my experience. What are we evaluating against? This is coming up as a more and more common issue now. Are we testing that the synthetic data gives us the same answers as the survey data, given that we know survey data isn't accurate? And if the only input we are using to build our synthetic data are survey data, then yes, it should give us the same response. But if we're using Twitter data, census data, media transaction data, loyalty card data, we should probably be evaluating the synthetic data against real market outcomes, not against what the survey data alone would have told us. So quick overview, and then we can go to questions. And I've not been able to read any of them, but I can see there are quite a lot of them. Potentially, this synthetic panel type approach, the personas, is going to have a much bigger impact than boosting or augmenting. Boosting and augmenting can't replace primary research. For some projects, this could replace primary research if it worked and if people believed in it. Once built, personas could replace data collection for some studies, but we would still need data in order to build more personas, to update them and move them forward. But they could also open up lots of options to use research. So when I look at the companies like Reckitt who are using synthetic data for screening, they're testing more things. Their budgets are not lower. They're doing a lot of research which is costing less, so they're doing more research. That potentially is a good thing for the world. It might be a bad thing for some companies. And we're also seeing, this is something we really do need to keep an eye on, a bifurcation of approaches in terms of synthetic personas. There are essentially two camps. The first are those like the Tolunas and the Qualtrics and the Ipsoses and so on, who are grounding their synthetic panels in survey data. They're potentially adding non-survey data to it for increased accuracy, and they operate within the MR rules. They operate within the MRS guidelines, the ICC SMR guidelines, the Insights Association guidelines. And then we have other companies who are coming into the industry, and a lot of these names that I showed you earlier are brand new names. Some of them are using non-survey data only, and some of them are just using LLMs, which for large-scale quant studies strikes me as a little bit risky, let's say. They're often operated by new entrants, and many of those companies, not all of them, I can see a highly respected one is in the audience here today, and none of this would apply to them, but those can be unaware of MR rules and MR guidance. So when they publish a study and they don't say it was done on synthetic data, they may simply not know that in our world that is unethical, and be unaware of the Article 9 in the ICC code, which mandates that any significant use of AI is declared in the findings. So that's a slightly longer run for me than I would normally do, but hopefully that has been interesting and useful. I'm going to take questions that are in the chat first, and then I will go over to the Q&A. Okay, we've got questions about echoes first, and hopefully that's all been solved. So you say when it's done well, it's better than waiting. Is anybody doing it well? Pretty much anybody who is, you're going to see them at MRS conferences, you're going to see them at the SMR conferences, the Insights Association, the Fair Gens, the live panels, the Ipsoses, the Tolunas, Cantars, all of these companies don't pump out rubbish. And so they're using really good techniques. They're applying machine learning. They're applying statistics. There's almost no LLM usage in most of the reputable companies who do boosting and augmenting of data. It actually doesn't require it. It responds better to statistical machine learning type techniques. Where they do tend to bring it in is if they try to replicate the open-ended comments, then they might use it there. So yes, quite a lot of people are doing it well. It's not every data set is amenable to it. Maybe someone can ask me a question later about good and bad data for that. Accuracy in a paper is based on having similar direction of differences, not exactly similar results. Yes, and actually there are several caveats in the way that Stanford and Google did their measurements, but they do actually write it all down there. So they deducted the retest of humans. And so they were 85% as good as humans were, but humans were only 90% capable of doing their own score. So it was something like 85% of 90%. So it's always worth looking at what's going on. The problem evaluating how reliable are synthetic data that you talk about is very important. Also, to me, it's not clear what are the techniques that are most used for this task. They are evolving. So if we talk about synthetic panels, the methods that people are using to draw on that inference and the way they're bedding them together are different from company to company. If you are a client, you can ask them, because you won't be a client if they don't tell you how they're doing it, at least in algorithmic terms. There will be some secret sauce in terms of the exact weight they give to this element or to that element. Likewise, in the boosting data, there are some real differences. You'll find one company using Gaussian couplers, another one will be using generalized adversarial networks, somebody else will be using a diffusion model. But again, you can ask them for that. What are your thoughts about the applicability to B2B markets? Absolutely as applicable as anywhere else, because this is about how well can you model the answers that humans would have given you, and whether you're asking them to give you answers to questions about breakfast cereal or John Deere's tractors is going to be broadly similar. Your sample sizes are going to be smaller, very often in B2B, so you're not going to be able to use the techniques that rely on big chunks of information like that. But people are using synthetic approaches based off qualitative information. If I've got a lot of interviews with the buyers of tractors, you can extract a lot more information from that. So how do you usually validate that the outputs actually reflect real user behavior, not just something that looks correct? So you have to really, at the start of the project, set things you are going to measure. And you might be looking to measure characteristics like how many people have got a driving license, things that crop up in official statistics, or things that you know the answer to from your sales information. So you know that the caffeine-free only sells as much as the regular cola, and then you look in the data to see if it's coming out. What validation framework would you trust most for synthetic personas, holdout comparisons, downstream decision accuracy, or real-world outcome checks, and why? It depends on the context. For boosting the data, holdouts is what I'm looking for, definitely. By the time we're into synthetic panels, I am probably, if I were going to be the client, I would want to put in some real world measurement things and see that they were coming back out of the data. But I also want to be checking that they weren't put into the data in order that good scores were achieved. And that's possible too. So now I'm going to switch across and look at the Q&A tool. When will the presentation be available? So you'll be able to download these slides in an hour or two. The recording from today's presentation will be available probably Monday. It could be tomorrow. Are you aware of any open standards for evaluating synthetic data effectiveness? I really worry about vendors cherry picking their validation tests. How do we compare models against each other? So I'm currently in discussion with about 20 marketing scientists from a wide range of organizations. Most of them are from vendors, but there is a desire to create more evaluation frameworks which are fair to everybody, because they all tend to have quite a lot of confidence in their system. And so we are working on that, but they are quite technical. Obviously, you can describe them at a non-technical level, but when we start talking about is the structure of the data comparable, that is different. And there is wide agreement that we should not just test the means from one set of data to another. Why is number 3 in that list called synthetic? Because it's based on real respondents. Perhaps because it's the oldest. And so that type of synthetic data dates back to, I think, the early 1900s, where you wanted to make a set of data that the statisticians could use from the census that would not reveal people's identities. And at that time, and I'm guessing I'll go back later and have a look at this, but I'm guessing they wanted to emphasize it was not real data. If people thought their real census data was being released, there would have been a lot of concern. By choosing the word synthetic, it probably made people more comfortable. Many people today don't like the term synthetic for the sort of thing that we're using. They would much rather use model data, for example. A key use for boosting of protecting sensitive material, MPD, reducing the number of human respondents, supplementing with synthetic helps protect sensitive material. Absolutely. I probably missed quite a few things. But that would be one. The paradox for boosting niche groups is that you shouldn't expect the data to be similar. That's why you are boosting in the first place, to help stabilize results. So you need to look beyond similarity. So I didn't mention hard to reach because I take a different view, and I think a view very similar to the person who made this comment. If I need a sample of 5,000 people to get enough users of this particular fragrance, then boosting is really on strong grounds because these people are probably just like everybody else around them. They're buying another variety, but they're not fundamentally different people. But if we have hard to reach people, so let's say we are talking about, we're finding it hard to reach socially disengaged teenagers. So we take the people we did collect, the teenagers we did get, and we boost them. Well, they're the not disengaged. They're almost the last people that we would want to use. And this is even worse when we use weighting. So where the hard to reach people are actually different, then we run into more difficulties. And that is why I tend not to be talking about boosting is good for hard to reach. It's good for expensive to reach. November 2024 is a long time ago for this topic. Things do move on. That paper was a seminal paper. It was what really started that strand of digital twins. We now have probably 30 companies who are selling products in that space because of that paper. For synthetic panels, you mentioned that the panel companies have large stores of data. Are they using their own proprietary data or the data collected on behalf of clients? I guess the idea they're using my proprietary data to train their models concerns me. To the best of my knowledge, they are all sticking to the terms and conditions. Some of them have been changing the terms and conditions to allow them to use the data. So you need to look at that. But the panel companies also collect an awful large amount of profiling information and stuff like that. So their own databases are very large. And if you take companies like Ipsos, for example, then they are doing many, many studies for Ipsos where they do have more access to that information. But I think that it's well worth you having a look, asking your software vendor, asking your panel company, what are the terms and conditions? What can they see? What can they use? How reliable synthetic data you talk about is important. It's not just clear what the techniques are that must be used to do this. It's an emerging field. So you need to press anybody who's selling you these services. Keep an eye out for some upcoming publications in terms of frameworks. We've got a very similar point there to the point that was made earlier. So moving back to the chat. Again, so this question here, you've said that synthetic data from synthetic panels only works if that kind of question has been asked before. Do panels usually tell you that? What is it reasonable for you to ask them and to share about what has been asked before? So as it happens, I was talking to Leger yesterday. Their panel gives you an estimate. Their synthetic panel, smart personas. I'm sure lots of the others do too. It's just this is one I actually know. And so it's giving you an estimate of how good it thinks it is. And that is partly based on how similar questions to this have been asked in the past. So that is a fairly nice way of doing that. And I think that these are the sorts of things that I'd like to see the Global Data Quality Initiative. We've got a session coming up soon on synthetic data and artificial intelligence, SMR, the MRS, Insights Association, to start talking about what is a fair disclosure within the process. So is it better to use personas, for example, 500 personas, each trained on the data of one real person, or to train one model on 500 interviews and generate 500 personas? I think the jury is out on that. My gut feel is that I would like 500 models, each trained on a single person, if I've got more than one survey for that person. So if it's an online community and I've got 2 or 3 online discussions and I've got 2 or 3 surveys for them, then that is going to be richer. The reason that starting with the 500 might make sense is that what happens is they design what the multidimensional space looks like. They look at what the hypercurves are. They look at the distribution across this hyperspace, and then they allocate points to it. So by starting with the 500, you have got a better chance with those sorts of statistics and modeling approaches of ending up with something which is a good match to the real world in total, but doesn't match any individual. We ran a comparative study at Track 7 on synthetic data to look at its accuracy and limitations. And there is a link there in the chart. I think it's great when people run these studies. There are quite a few at conferences. Quest Mindshare, I've done 2 or 3 where they looked at boosting and they published the results. And nobody asked the question that I asked you to ask, so I'll answer it anyway. What sort of things does it do better and worse on? One of the studies we saw in the Quest Mindshare publication, they were looking at Latin America, its aspects of masculinity, questions where most people agree the synthetic data was really quite good at replicating. But one of the questions it was quite bad at was, there was a question there that same-sex parents can bring up children just as well as heterosexual couples. And that divided people. There were a whole lot of people saying, yes, absolutely. And a whole lot of people saying, no, I don't agree with that. And that was harder. So that's the first type of thing where the synthetic data struggles, where there is this hard, fast, and it's a bimodal distribution. There's nothing in the middle. And then the next sort of categories, the yes-no questions. So 5-point scales, 7-point scales are much easier for synthetic data to get right than having to say this is a yes or this is a no. So even designing your studies can have an impact on how well synthetic data will later on be able to help you with that, boost them, replicate them, move beyond them. So all of that is quite interesting, I think, going forward.